All right, we're going to be looking at our next type of probability here, and it's called geometric probability, and it really has nothing to do with geometry, but what it is we're going to do something a number of times until we get our first success. So in this case here, the latest research out there shows you that 16% of Americans have blue eyes. So using that figure here, we're going to answer a series of questions here, and all these questions have to do with geometric probability because, like in this case here, it says, what's the chance that the first person who has blue eyes is the sixth person you choose? So you're going to keep picking people until you find somebody who has blue eyes. Same thing here, except this time it's the first person with blue eyes is either the third or the fourth person, etc., etc. So it's all about going until you find somebody who fits a certain criteria, in this case blue eyes, and then you stop. So let's go over how to do this kind of probability. So the first question is, what's the chance that the first person who has blue eyes is the sixth person you chose? So you know that the chance of success of getting blue eyes is 16%, and we use Q as being the chance of failure, and therefore 84% of people therefore do not have blue eyes. So this is having blue eyes, and this is not having blue eyes. So you could figure this out really quickly by doing this. Well, we're not going to have somebody with blue eyes until the sixth person, so that means the first 5 people that we go ahead and pick are all going to not have blue eyes. So these are our 5 people here. They all have an 84% chance. So what we would do then is we're going to go ahead and multiply these together. So obviously we don't have to write it out 5 times. You can just write 0.84 to the 5th power. Now our 6th person is going to actually have blue eyes. So that's 16%. So what we're going to do is we're going to take 0.84 to the 5th power and multiply by 0.16. So grab your calculator, go ahead and do that. So 0.84 to the 5th power, and then multiply by 0.16, and you should get about 0.067. Well, there's about a 7% chance that this would happen here. So once again, notice we're getting 5 people in a row who don't have it, and then we're getting somebody with blue eyes and then stopping. All right, next question here. What's the chance that the first person with blue eyes is either the third or the fourth person you choose? So if you're going to do the third, or it could be the fourth, what you want to do is you want to figure out each of these individually here, and then or means add them together. So for it to be the third person, it means 2 people in a row don't have blue eyes. That's 0.84 squared times 0.16. Whereas for the fourth, it would be 0.84 to the 3rd power times 0.16. And then you figure out each one of these individually here. So 0.84 squared times 0.16, and then plus 0.84 to the 3rd power times 0.16. And once you do that, let me see here, I'm having a little issue here with the calculator, times 0.16, and the answer is 0.208. So there's roughly about a 21% chance that would happen either on the third or the fourth person. All right, moving on here. What if you want to find someone with blue eyes before checking the 7th person? Well, what that means is we want to find it either on the first person, or the second, or the third, or the fourth, or the 5th, or the 6th. Now that's a lot of calculating here. So there's actually a shortcut for how to do this. So if you wanted to define this, first of all, this means anything that's 6 or lower. So we would write out the probability that it happens on the 6th person or lower. We'd write like this. Whereas X stands for the number of people it takes before you find someone with blue eyes. So there is a function on your calculator that can actually figure this out for you, where you can do 1 and 2 and 3 and 4 and 5 and 6 all together at the same time and then tell you the total answer. And what this has to do with, it's under Geomet CDF, and this is in the same area where normal CDF is, so you'd want to go to normal CDF, that's second vars, and then it's on the list down near the bottom here. So second vars, and it's called Geomet CDF, and what you're going to do is, in this case here, the chance of success is 0.16 because that's the chance of having blue eyes, and we want to know all the way up through the 6th person. So go ahead and do Geomet CDF, and then it's 0.16 and then comma 6. Go ahead and figure that out, and so the answer is 0.649. So this is a function that can help you figure out anything from 1 and above. And what I wrote here in red, once again, is what we call calculator talk. And if you have it, it's nice, but it doesn't count as full credit. But what you want to have is what I've written over here, the probability that it happens on or before the sixth person, and define x as the number of people before you find somebody with blue eyes. You can also use that to answer this kind of question. What's the chance you find someone with blue eyes after checking the fourth person? So this means if it's after the fourth person, that means it either happens on the 5th or the 6th or the 7th or the 8th or, etc. It could happen anytime up to infinity. So your calculator, when we do geomet CDF, only does 1 or higher. So what you need to do in this case here is, if you want to know the chance of 5 or higher, you need to think backwards. And the opposite of 5 or higher is 4 or lower. So you're going to go 1 minus the chance that it happens on or before the fourth person. Once again, how do you do this on the calculator? You're going to do 1 minus geomet and then CDF 0.16 comma 4, because we want it to happen on the fourth person or earlier. So grab your calculator, do 1 minus, go to where normal CDF is, and then find geomet CDF under the same menu. And make sure it says 0.16 comma 4 this time, and then go ahead, enter in the value, and you get 0.498. So our answer here is 0.498. There's almost a 50% chance of that happening. And our final one under geometric probability is, what about average number of people here? So it's a little bit different here. We're not looking for our chance, we're looking for the average number of people. And when you're talking about geometric probability, the formula is 1 divided by the chance of success. So in this case here, mu, our average, would be 1 divided by 0.16. So if you grab your calculator and do 1 divided by 0.16, the answer is 6.25. So it would take you roughly 6 people, maybe 7 people on average before you find somebody with blue eyes. So that's everything you need to know about geometric probability.